Okay, so this is misconception 2. So from your misconception foldable, what was misconception 2 talking about? They're talking about kids do not understand the relative size of fraction with the same whole. Misconception 3 is the same with a different whole. The important thing is same whole. So oftentimes kids think 1/10 is bigger than 1/5. Is this true? No. But why this misconception come from? Because they learned that 10 is always bigger than 5. All of a sudden, it's not bigger anymore. So that can be confusing for kids, right? So we talk about the fair sharing concept can be helpful to think about this. We can also use a fraction fair share pattern block to be able to talk about this. So this is a misconception too. So in the picture below, this is a crown, is 1. So remember that we always talk about what's your whole. So this is my 1 whole in fraction. And then we want to find out what piece that represent 1/2 and what piece represent 1/3, one piece represent 1/6. So they need to figure out how can you find out that. How can you find out that? So remember that we talk about the fraction strips. 1/2 means I need how many halves do I need to make my 1 whole? There are 2 halves. And 1/3 means I need 3 1/3 to make my 1 whole. 1/6 means I'm going to have 6 equal size pieces in my 1 whole. So I have to cut my 1 whole into 6 same size pieces. That's the 1/6. So I'm going to have 1/6, 6 groups of 1/6 in my 1 whole. That's the older fraction concept in here. So how can I find the 1/2 in here? So I told you that we need 2 groups of 1/2 to make my 1 whole. So what is my 1 whole there? Which piece represents my 1 whole? This, right? How do you know? Because if I want to replace this, my hexagon, using 3 triangle, this is the same as this, right? They're the same in size. If I put on top of here, they're the same. So I know that I can replace this one in here, then here. So I know that this is my 1/2, and this is my 1/2, and this plus this is going to be my 1 whole, right? So I know that it is going to be 1, my 1/2 is going to be a trapezoid. Okay? So this is a good way to you can use quick glance of the assessment, so you can let them figure it out as a group or as a table, as a pair, and then you can think about can you show me the piece that represent 1/2, and don't show me yet, hide in your palm, and when I count 3, show me your pieces. So kids are gonna show their pieces, then you can see them. If they pick this one or a 3 triangle, you can tell they got the concept. But if you have all different sorts of size pieces, then you can see easily that they are not ready yet, right? So it's a good way to assess quickly. What about 1/3? Then what's the 1/3 should look like? 1/3 means I would need 3 equal size pieces to make my 1 whole. That is going to be my 1/3. Does it make sense? So if I have this one, it's too big. If I have this one, I only need 2, so this is not 1/3. Then what else I can use? I want to try this. Do you think this one is give you the 1/3 in here? Like this? How do you know? If I place this on top of here, it's going to be 1, 2, 3. So this one is the same as my 1 whole. Or you can think about as triangle. 6 triangle. The same as this. Right? 6 triangle same as 2 trapezoid, or 3 rhombi. 1, 2, 3, right? So I can tell I would need 3 of this to make my 1 whole. So each rhombus represent 1/3. So 1/3, 1/3, 1/3 makes you 3/3, which is 1 whole, right? So my 1/3 piece is going to be this. So same thing in here. You can ask kids to, can you pick the piece that represents 1/3 if your crown is 1/2 and show me what it is. So if kids can show this one or 2 triangle, then you can say them they know the concept, right? If they have this one or that one, then maybe you can say, oh, I don't think they're ready yet. They don't got the concept yet, right? Does it make sense? What about 1/6? So I mentioned that this is the same as this one in here, right? So I know that I need 1/6. How many of them? 1, 2, 3, 4, 5, 6 makes my 1/2. So I know that this one is going to be my 1/6. Okay? So this is something you can think about it here. So now I have 1/2, 1/3, 1/6. So there's a question you think about it. Can you order the fractions from the least to the greatest? Explain how you know. So when you look at the size of fractions here, which one is the biggest in size? Looks like 1/2 is the biggest, and 1/3 is the next one, and 1/6 looks like the smallest. So kids can see it from them here. So I know that 1/2 is the largest, and 1/3 is next, and 1/6 is next. So kids can order the fraction here, and they can also can see, visualize the size of each fraction. Only if we have one same whole, same size whole, we can compare the size in here. So I know that this is bigger than 1/3, this is bigger than 1/6. So think about the fair sharing concept. Think about that this is your brownie here, right? And then one group gonna share this brownie to 2 people. Each one gets this side of brownie here, and the other group they're gonna share the brownie 3 people, so they're gonna have this size of brownie each, and 1/6 they wanna have this size of piece of brownie. So who gets the largest brownie? Who gets the smallest brownie? So kids can visualize the situation, so they can think about that. Not larger denominator is bigger fraction all the time. Does it make sense? Okay. So you can compare the size in here, and also how would you address misconception? That's what I just showed you. Think about the fair sharing concept and directly compare the size of each fractional piece. We can tell 1/2 is the largest compared to all the size there. Okay, good. So we just talked about that, right? So we can compare the size here. What if we want to use fraction strip? I want to use a fraction strip to teach the same thing. You can also do it. So this is 1/2, right? We talk about this is 1/2. And what's the misconception 2 says? It says not understanding the relative size of fractions with the same whole. So everything we are going to use this whole as a reference, right? So if this is 1/2, what does my 1/2 look like? 1/2 is this. How do I know? I need, how many halves do I need to make 1/2? I need 2 halves to make my 1/2. What about 1/3? If this is my 1/2, same size whole, what is my 1/3? My 1/3 looks like this. What about 1/6? My 1/6 is this. So what do you notice here? Compared to size or length of each figure, each fractional piece, what do you notice? Yes, I can see if the same whole relative size, 1/2 is bigger than 1/3. 1/3 is bigger than 1/6. 1/6 is the smallest compared to 1/2 and 1/3. Same thing in here. We have this 1/2, 1/3, and 1/6. This is the largest in terms of size. This is smaller. This is the smallest size here. So kids can see them. They can order the fraction in terms of their size. So they can see the why 1/2 is bigger than 1/6. They can visualize. Good.